Okay, thank you very much for inviting me. Like George said, this is the second time I'm doing this talk here at NUS for this master's course. But I've given several other talks in NUS also. The most recent one, I think, was in April, either April or May, where I did it at this SEER forum. And at that point in time, I spoke on waste management. So today, I want to speak on a slightly different topic, which is on environmental sensing. And I want to use it to actually draw in a recent event, which is the haze, something that I'm sure all of you have experienced before. And I want to give you all a little bit of a perspective as to what actually happened within NEA, within Singapore with regard to the haze, and what we're going to do about it going forward. So before I do that, let me just maybe just give a bit of an introduction as to who I am and what NEA does. Like George said, I have a kind of interesting background for someone in the technology office. I'm an accountant by training. I studied at NTU, I studied accountancy, and I started my career in Waterhouse. I was working in the tax department for about 2.5 years, and then I joined the Economic Development Board in their tax policy unit, and I spent about 13 years in EDB doing incentives, investment incentives, tax and financial incentive policy, and so forth. And it was a very interesting job. I became quite, in a way, a specialist in that. If you Google my name, you actually see my name. Actually, I spoke at one of the Asia tax forums, which I think was either in 2006 or 2007. So, you know, sometimes it's quite unusual. Like you Google my name, you see taxation, and then suddenly you see human capital, which was another of my roles in EDB, and then suddenly you see climate change and so forth. But it was in EDB that I started getting interested in climate change and sustainability issues. And so I moved from the tax policy unit into a more frontline role. I did industry development, specifically in education sector, professional services, and I also did it in the engineering services sector, which looked at green buildings, energy efficiency, and so forth. And that kind of like spurred my interest in this whole climate change, sustainability, environmental management area. So when there was an opportunity at NEA to come into the Environment Technology Office, they asked me where I was interested. I said, yeah, sure, why not? So officially now, I'm actually seconded to NEA from EDB. I'm actually still officially a staff of EDB, but NEA pays my salary. And I really like the job, and I'll share with you some of the things I've learned in the last 2 years that I've been in NEA. Okay, so that's about me. Okay, what does NEA do? Some of you all may be familiar with it, but for the benefit of those that are not, NEA covers a very wide range of activities. We basically have three, you could say, verticals that define our operational areas. The first one is on environmental and public health. So that's where you will see things like for us managing issues like food hygiene, dengue, which is of course a very huge thing in Singapore this year. But not just dengue, but many other vectors, you know, like rats and pests and so forth. And we regulate things like clean toilets. So many things to do with public health. We are there. We're also involved under that division to look at things like public cleanliness. So we enforce things like anti-littering, anti-smoking. We're also involved in building hawker centers, which after about 25 years, we have finally started a major round of building hawker centers again. So that's something new for NEA that had been dormant for many years. So that's the first vertical. The second vertical we do is on environmental protection. So that's a traditional kind of environmental unit that most environmental agencies do. And within that, we have obviously pollution control. And pollution control covers everything from air to coastal waters, to noise, to smell. Then we have energy efficiency, and of course, our biggest public, in a way, infrastructure is in solid waste management. Okay, that's where you find the 4 incineration plants that we're in charge of, and the entire waste collection system and so forth. So the way that we divide it between us and PUB, which is another step board under the Ministry of Environment and Water Resources, is that PUB takes care of anything to do with water, obviously. So the whole wastewater collection system, the water reclamation into new water, and then desalination of seawater, that's under PUB. That's under the sewage department. Now, of course, recently they've been in the news because of floods, right? So that's the other thing they're responsible for, which is their water catchment, the drainage, and everything. So they take care of water, we take care of solids. Okay? And it's not always the most, I would say, from an environmental point of view, efficient way of demarcating it. Okay, that's my personal opinion. It's a legacy. And the reason I say is because if you really think about it, actually waste, it should not be split between water and solid. Actually, it should be split between organic and inorganic. Because organic waste, most of the time, you have a different process of treating it as more efficient compared to inorganic waste. Most of the time, inorganic waste, you can recycle it, whether it's glass, or it's metal, or plastics, and so forth. But that's the reality of what we are structured. But for the next few waste treatment plants going forward, we are looking at how we can actually integrate some of our operations. So like I said, we also do energy efficiency. We cover all sorts of stuff. In even radiation protection and so forth. That's under environmental protection. Now the third arm of NEA that we do is actually under meteorological services and climate change. So weather prediction, in a way certain natural disaster, natural hazards kind of prediction like tsunamis, earthquakes, those also fall under NEA. And of course climate change is something that is going to hit us in a very big way. So about a year ago, we actually set up the Climate Change Research Center in Singapore, which is actually headed by the person that used to head the UK Met Office Hadley Center. And what they're trying to do is really to take a lot of these global climate models and try and downscale them to our region. Because there's very little modeling done on tropical climate change, and there's very little data that's been collected. So I think there's a huge gap that we need to do it in order to kind of see what we can do to adapt to the effects of climate change. So, in a nutshell, that's what NEA does. Very diverse. What does my office do? We do two things. We support the whole NEA in test bedding of technology to further improve their operations. So in that respect, we work as a sort of like CTO office. The second thing we do is we fund research. We fund research involving universities, polytechnics, and industry to build up capabilities in environmental management. Most of the time, what you have seen so far in the news, if it ever comes out on NEA projects, have tended to be on solid waste because that's where most of the funding is going to be. But going forward, you'll see that we'll be expanding a lot of our funding areas to other areas beyond solid waste. So like I mentioned, we do public health, we do energy efficiency. So slowly we're going to be spreading our areas in many of these areas as well. So if after this, any of you have questions about NEA, you can come and talk to me, or you can check out our website. It's nea.gov.sg. Okay, so what am I going to talk about today after this introduction? If you look at the synopsis that was sent to you, it's very unexciting. It just says future environmental sensing technologies. There's a reason for that, okay? You know, things, once you're on the internet, they're there forever. And I didn't really want things out there that have titles like I Know What You Did Last Summer, okay, which obviously is a horror movie from Hollywood. But I wanted to actually spend the time this evening to actually tell you, in a way, a story of how this year we fought forest fires in Sumatra, and how we use environmental monitoring in our journey, and what is the future of environmental monitoring going forward, not just for haze, but for the other aspects of NEA work that I talked about. So because it's a story, you know, it has to have a beginning, right? So this is how it all begins. Okay, it all begins in Indonesia. If you look at the statistics for Indonesia, in 1990, Indonesia had 121 million hectares of forest cover. Okay, that makes it the third largest tract of rainforest in the world, after the Amazon and after the Congo. If you go to Indonesia, to the places whereby rainforests are still in abundance and have not been cut down, you go to places like Papua, you know, you'll see this is how the world looked like before human beings colonized it and started expanding our cities and cutting the forest down. But it's a reality, okay? Deforestation is a very big problem all across the world. It's a very big problem in Indonesia. Between 1990 and 2005, in the lowland forests of Indonesia, from Sumatra and in Kalimantan. Indonesia lost about 40% of its lowland forest cover. How much does 40% work out to? It works out to 15 million hectares. That's 1 million hectares of forest cover that's lost a year. Again, what is 1 million hectares? Okay. Singapore is 70,000 hectares. So 1 million hectares is 14 times the size of Singapore, lost every year for 15 years. And these are statistics up to 2005. From 2005 until now, it's the same. If not, it's getting worse. And it's likely to continue like this for the foreseeable future because it's all driven by developmental pressures. Obviously, forest fires are a big consequence of deforestation. Okay, they were true in the Amazon about 15 years ago. The Brazilians have actually managed to stop deforestation significantly. For us in Southeast Asia, I dare say actually we have only just started on this journey, which is why you see things like the haze becoming, in a way, increasingly worse over the years, potentially getting worse over the next few years. It's just a phase of the development that the Brazilians had gone through, and they had done many things to actually stop deforestation. We have to do the same thing, likewise in Southeast Asia. So this is a picture that you see in Riau in 2005. It's a NASA picture taken by one of the NASA satellites that actually pass over the region once a day. In Rokan Hilir district, you see this huge smoke plume that actually comes out of northern Riau. It goes across the Straits of Malacca and it goes all the way to Peninsular Malaysia. And as I'll show you in many pictures later, Singapore is actually very fortunate. This year we got the haze very bad. Malaysia actually gets the haze every year. The reason we pay attention to it more this year is because it was very bad for us. Actually, Malaysia gets the same haze every year. Which makes them a little bit more fatalistic about the whole thing. Because they themselves have huge forests that they cleared it, right? So, actually to the Malaysians, they are maybe a bit more blasé about it. They view it as, well, this is just part and parcel. We went through the whole cycle before, so Indonesians are doing it. We are an agricultural country. We understand, slash and burn, it happens and so forth. They are a lot more accepting about it. Every year in ASEAN, there is a burning season. Haze comes to our attention somewhere around the middle of the year to October, because that's the time it starts to affect us. In actual fact, if you look at the NASA satellite data, haze is almost a year-round effect. This shows the hot spots taken by the MODIS satellite. Okay, there are actually two NASA satellites that pass over our region every day. Okay, one of them is called Aqua, one of them is called Terra. Okay, but they both carry a sensor that's called MODIS, and MODIS is one of the sensors that are used to detect hotspots. If you take a look at the February 2012 picture, you'll see that the hotspots are actually concentrated in northern ASEAN, basically in northern Indochina. See, what happens is that the burning season in ASEAN actually starts at the end of winter in northern Indochina. So around January to February, they start burning. Okay, in Myanmar, in northern Thailand, in Laos, and so forth, you can see from all the hotspots. And this trend, in my opinion, is going to get worse because Myanmar is opening up. And it's probably a free-for-all land grab over there. Okay, so 2012, you'll see, okay, at the end of winter, hotspots all concentrated up in the north. Then it starts to spread downward because that's the pattern. As the dry season spreads southwards towards ASEAN, the hotspots follow. By June, you'll see the hotspots are concentrated usually in Sumatra, in Riau, could be in North Sumatra. Some of it starting to spread to southern Sumatra, to Jambi in the south. And then by September, the hotspots start to die off more in the Riau area, but they start to spread south. Okay. South of Riau province, of course, is Jambi and then South Sumatra. So this is the pattern. And which means that actually throughout the whole of ASEAN, for about 10 months a year, there is actually burning of forests going on somewhere. There's actually haze going on somewhere. It's just that it's not really to our knowledge. But this year, we are more aware of what goes on in our surroundings. And I'll show you some pictures that actually show that even some of the early burning in the year did start to affect us. And it's worse. During the Great Burning of 1997 to 1998, forest fires raged out of control for months across Kalimantan and across Sumatra. WWF called this particular burning, a planetary disaster. 5 million hectares of forest were burned. A lot of it in Kalimantan. It released between 1 to 2.5 gigatons of CO2 into the atmosphere. How much is that? That's approximately up to 40% of the annual global CO2 emissions from burning fossil fuels. This is just from forest fire. This is the reason why Indonesia is one of the largest CO2 emitting nations in the world. Okay, it's not because of their manufacturing sector. It's because of deforestation and forest fire. Okay. So this happened during a very bad El Nino year. This year, when we had it very bad, it wasn't even an El Nino year. In fact, it's neutral. It's slightly La Nina in fact. And that's what makes us concerned, because El Nino, La Nina, these are all just cycles. Eventually, we're going to have a huge El Nino year. And what's going to happen if we don't take some action to stop the forest fires in Sumatra? So how did it all begin? Okay, that was the background. Well, I got interested in this whole area of haze when I first read about Willie Smith. If you haven't heard of him, you can go and Google, and he has a couple of talks on the internet. You can look at the one on TED. It's quite interesting. It's only about 20 minutes long. I met him a couple of years ago when I was in Singapore, and I was very intrigued because in a place called Semboja Lestari, which is near Balikpapan in East Kalimantan, he did something that was quite amazing. He bought a tract of land that had been deforested and had then grown back into nothing but lalang grasslands. And lalang grasslands, if you know, they can't really support any other crops at the onset. And they are very fire-prone. Because that's the way lalang propagates. It actually propagates by fire. So every year, this plot of land would have a drought, and then it will catch fire, and then obviously, there will be a lot of haze and so forth. So he started this project in Semboja Lestari, reasoning to himself, if he could convince people that he could take this, the most degraded type of rainforest land, and regrow a rainforest on it, then no one would be able to say that regrowing a rainforest would be impossible. So this was how it looked like in 2002. And 4 years later, he had managed to regrow this vast expanse of new forest. And this is what he claims. All right, I say what he claims because Willie Smith he's quite a character. He's a loner. He doesn't work well with people, and most of his projects have never been peer reviewed. So if you read the internet, there are also many skeptics that say that it's a scam. There are many people that have serious doubts whether he managed to achieve what he claims to have achieved. But okay, let's take it at face value. Okay, the forest is there. The new forest is there. Okay, for sure. Okay, you can see with your own eyes. Temperature is down, humidity is up, rainfall is up, and 3,000 people are getting income from a forest. How did he manage to do it? Well, very simple. He managed to introduce a system of agroforestry, whereby he used this tree called the sugar palm, and then he planted it all over a place. And sugar palm actually grows well in secondary forests. Okay, so it's not like all palm whereby it's a monoculture. It actually grows well in secondary forests with other kind of food crops and cash crops. So it's something that looks like a forest, but it's economically useful to the people around there. So it provides food for the animals, the orangutans, which was the animal that he was trying to conserve. And of course, it provides food for the people that they can sell. So there's an economic reason why people want to preserve the forest. And that was what he was trying to get at. He realized that even though he started off as an orangutan conservationist, there was no way that he could save the animals if he couldn't save the forest. And there was no way he could save the forest if he couldn't provide the people living in the forest a reason to want to preserve it. Because, if you're poor, just telling you to just not cut down a tree carries totally no weight at all. Okay, because between starving and cutting down a tree, it's clear, right? You just have to cut and do whatever you can to feed your family. So he had to find a reason to get them to preserve the forest. And in Semboja Lestari, and also in another place where he lives in Manado, he managed to do the same thing. So I was very inspired by his story, and even before I went over to NEA, I wanted to do something about haze, which is why I approached people in NEA and I said, I heard about Willie Smith, and there's something I really want to do about it. What can I do about the haze? So by the time I came into NEA, it was something that I had a passion for. So even though it wasn't really within the scope of the environment technology, or it was something I put on my hands who volunteered and said that, I really want to try and see how we can stop forest fires in Sumatra. And of course, around June last year, there was also a haze, not as severe as this year, but as you can see, air quality was worsening. As is normal in June every year, in Singapore and Malaysia, you'll see the PSI inching upwards because the forest fires have started in Riau province. So one of the things I first did in NEA was I gathered a group of like-minded people who wanted to do something about the haze. And together we decided we would build a prototype. A prototype haze monitoring system using Google Earth. And this is what we did, okay? We went to Google Earth, and in fact we approached Google, we asked them, hey, how do you do some of these overlays? And they show us for free. And we overlaid 3 data sets, okay? We had the hotspot data, which is publicly available because it comes from the NASA satellites. It also comes from the NOAA satellites. All this can be, downloaded every day if you want to. We had satellite, high-resolution satellite imagery, some of the things that you see here. I'll show you some more photos. And then we managed to find concession maps floating all over the internet. Unofficial ones, okay, but which look pretty authentic. And so we started to overlay them. And these are some of the photos that we found. When we overlaid it over the Riau forestry concession maps, we found that there was repeated burning over the same sites. So in June 2005, you can see, this was that picture I showed to you on Rokan Hill here. Huge smoke plume, okay, coming up from one of the concession areas and floating across to Malaysia. But take a look, okay, July 2006, same area, okay, this is a more high resolution photo. And you'll see these are the annotations that NEA, or rather not NEA, a satellite center in NUS, CRIS, okay, if you have not visited, it's somewhere nearby. They actually do this on behalf of NEA, and then they send it on our behalf to Indonesia. Every time there's a forest fire, they actually send all these pictures, which of course contain the exact coordinates, and then they send it to Indonesians to tell them this is where the fires are, please take action. So it's the same place in northern Riau province. Okay, July 2006, June 2009, same zone. Okay, as you can see, concession area number 15 here, right? There's repeated fires over the years. June 2012, okay, this was when we started this Google prototype. Huge numbers of fires on concession number 15. And of course, we could identify concession number 15 because we had the maps, okay, they had the index, okay, we know the company that's listed on the maps. Okay, this is another view, June 2012. You see the plume, okay, the very clear plume spreading out from a very defined area and floating across the Malaysia. And this company that was naming, using the map, it wasn't unknown. We did our own research and we found out that actually NGO and media reports in previous years had already identified burning within this company's concession. So it's not something that was unknown. And there's an NGO in Riau that's very active in Riau called Eyes on the Forest. They actually also recorded, they do their own hotspot counting, and they identify this company as being one of those at the highest hotspot counts in June last year. So we showed all this to my minister, Mr. Vivian Balakrishnan, and he was very interested. They said, hey, you guys are on to something, which is why you see him talking so much about haze monitoring system. This is how it actually all started. This is actually the inside story as to how it started. This post of his that he put on his blog was on 31st October last year. I was with him in Bali for a few days before that. And this was what I demonstrated to the ASEAN officials that were there. Okay, to Indonesia, to Malaysia, to Brunei, to Thailand. Singapore also, of course, was there. And the ASEAN officials said, okay, I mean, what you are doing looks interesting, so why don't you go and develop a system? Okay, give you all the go with it. And so he came back and he put this blog post that says that, look, we are going to start exposing errant plantation companies that are causing transboundary storms. This was actually how it started. But what we are doing in terms of building this haze monitoring system is actually not a new idea per se. The way it started actually was, I read about it. I read about something similar by a company called Amazon, who had a forest monitoring software that they use in the Amazon forest, which they developed with the help of Google Earth. And it was very similar, putting satellite imagery, maps, and so forth. And I wanted to do the same. This was how we created the HMS. And then we realized, of course, hey, even though, you know, we put all these together and it's like on the fly and doesn't look like, you know, it's been done before. In reality, the NGOs have been doing it for years, and they've been writing these reports and naming specific companies for years. So you can see Greenpeace has been doing over the years. This is a 2007 Greenpeace report. Ice on the Forest, okay, the NGO I mentioned before, 2009. You can see they have concession maps. They plotted the hotspot data, and of course they name the companies. So none of what we are doing is new in a sense. The only thing that's new is that you could say the government put its weight behind it and made it a lot more public than it really was. And the NGOs have one advantage. They have people on the ground. So every time they do something on deforestation, they don't just have the maps and they just don't have satellite photos. They can actually have people on the ground to take photos, which we call ground truthing. And these are, of course, ground truthing photos taken by Ice on the Forest on deforestation. So our aim really when we created this HMS was eventually for a system that will not just have your satellite photos, but to have people on the ground. In a way, crowdsourcing data to take pictures of actual burning or the aftermath of burning, and then we could actually plot them on Google itself. So this was how it all started. And the NGOs had been doing things like that for years. One of the biggest battles they fought in Indonesia in recent years was for a peat swamp called Tripa. Again, you can go and look at the internet and go and see its background. Basically what happened is that Tripa is a peat swamp in Aceh. It's very famous for its biodiversity. And in this peat swamp, in August 2011, the Indonesian government assigned a concession for a palm oil plantation. And this got the NGOs very annoyed, not just because it was on a place that was very famous for biodiversity, but because that piece of land was actually protected under the Indonesian National Moratorium on Deforestation. It was actually marked under their map to be protected under the moratorium, but yet they have been given up as a concession area. So you may ask, okay, what's a peat swamp? Okay, it's important to know because this is how most of the coast of Sumatra looks like. It's actually a very wet forest. It's a swamp. Basically, it's sort of like a wetland. And when they need to develop it for oil palm or whatever else they want to grow, the first thing they do, obviously, is they have to drain the peat swamp. So they dig canals, and then the peat swamp is drained, which means that the peat starts to settle, because usually it's a peat dome, right? So when you drain the water, everything settles in. And then as the peat dries, it oxidizes. So oxidation causes CO2 to be released, which is bad by itself, okay, even if you don't burn. But then peat is also very flammable. So when it burns, it smolders for weeks. And that's the danger of a peat fire, because if you don't put it out within a few days, the peat fire can smolder underground for weeks. And it looks like it's put out, and then a few weeks later, when it's dry conditions and the wind picks up, it actually flares up again. So it just smolders with a lot of smoke. You just imagine it's like charcoal, right? You think you have put it out, it actually smolders. A tremendous amount of haze is created by peat swamps, fires, and of course, CO2 is emitted as well. So in Tripa, they found out that there have been fires over the last 10 years. Okay, so all these NGOs started mapping, and the area that was controversial was this part that's actually bordered in yellow. Okay, it was assigned to a company called PT Kalista Alam for oil palm. And the interesting thing is that this hotspot data is from 2000 to 2010. Now remember, the permit was actually given to PT Kalista Alam only in 2011. But you can see fires started even before that. So obviously there have been illegal encroachment into this area. And there have been fires, which under Indonesian law is 100% illegal, okay? Open fires in Indonesia is totally banned as a form of land clearing. It doesn't matter whether you're a small farmer, big farmer or whatever, it's actually supposed to be banned totally. Okay, so this is illegal, it's been carried out through illegal encroachment. It's been going on for 10 years before that, and yeah, the potential will get worse because obviously once you assign the concession, the first thing you want to do is to clear the land as soon as possible. So this guy, and you can take a look at this link, is this guy called Graham Usher, who I met last year. He was quite diligent. He plotted all the concessions that were within the TRIPA area, and by month, and you go and count annually the number of hotspots in there. So it created so much international pressure that finally Indonesia revoked the palm oil permit. This was done in September 2011. And this was regarded as a huge victory for NGOs, because I think before this, no one had ever successfully stopped the concession permit from being given out. This was actually a reversal of it because of international pressure. And the international pressure wasn't just on the Indonesian government. What the NGOs did was they targeted the purchasers of palm oil. Unilever, Cargill, Nestle, and they kept on telling them, do you know where your palm oil comes from? You're buying it from Sumatra, how do you know it doesn't come from TRIPA? And so forth. And NGOs can be very effective. What they did for Nestle was all these activists dressed up in orangutan suits, and then they just demonstrate literally outside Nestle headquarters, and they kind of trolled Nestle, right? They climb out the building and they put this huge banner, and then of course it embarrasses Nestle in front of the whole world. And that's why Nestle for a time actually stopped buying palm oil from companies that were accused of deforestation. So a lot of this NGO public pressure actually is quite effective. So they use the same thing for TRIPA. So TRIPA, when the permit was revoked, was regarded as a huge success. But in Indonesia, nothing really follows the way it is. I don't know what's the latest with TRIPA, but I followed it at least up to May. And as you can see, another court then said that, no, sorry, the permit, the decision to cancel the palm oil concession is not correct, so I'm going to reverse it. So in the end, is TRIPA protected? Will it continue to be conserved? Who knows? Okay, it is Indonesia, right? You never really know what may happen. So it's within this backdrop that we entered the haze season for 2013. Okay, we know about these pressures that are going on. We know these are the challenges facing us. So we were in a way ready for the 2013 burning season, because remember by then, the very rudimentary haze monitoring system using Google, we had a sort of prototype up and running. And so in February, when the burning started in Indochina as scheduled, we were aware of it. Okay, you can see between February 2013 and February 2012, the burning happens in the same area every year. So there's no way that this is a natural fire. This is clearly a man-made fire. It happens in the same area every year. This was in 19 April. Okay, and so we used the HMS, the haze monitoring system, to try and trace. Okay, for the first time, could we in real time figure out who was doing the burning? So we again, took the hotspot data, the concession maps, and so forth, and we found that on 16 April, there was a cluster of hotspots happening at the edge of concession number 21. And then we kind of corroborated it by using the data from CRIS, which is the NUS Satellite Center. Because on 16 April 2013, okay, they had MODIS pictures that showed a plume of smoke arising from around the same area. Okay, so this kind of made us have the confidence that if we really wanted to, we could in reasonably short period of time, assuming there's no cloud cover and everything, we could theoretically identify who was doing the burning, or at least we could tell where the burning was taking place, okay, rather than just being in the dark. Now, what caused the haze to be so bad this year? If you look at past statistics, the traditional peak of haze season in Singapore is actually in September, but if you look at the right side, for us it peaked very badly in the middle to the end part of June. So what caused it? Three factors really, okay? And I will use this to illustrate how NEA actually does environmental monitoring or meteorological monitoring and so forth. Three things happened that made it very bad. Firstly, there was a very huge increase in hotspots in Riau. We had drier than normal weather conditions, and I think most important of all, the winds were very unseasonal. They came from the west. So what caused all this? When I went to Indonesia for the emergency haze meeting, I think that was on the 18th of June. And we faced the Indonesia. It was very interesting. You see, the Singapore delegation was one side and the Indonesians on the other side. And the head of their forestry ministry, I think the Secretary General, the thing is just started off was he said that, oh, the haze is actually caused by a tropical storm. I mean, I have to admit, I wanted to laugh. But as it turns out, actually, it wasn't really wrong. There were some anomalies in the weather patterns. So let's take a look at this map. There were two things that happened then. Okay, we had tropical storm Lipi to the east of the Philippines. Okay, you can see that, that storm forming there. And then we also had a low pressure system that was forming to the south of Sumatra. Now what happens is this, basically. Just imagine, most of the winds, the normal winds, actually move from Australia. Okay, they will tend to move this way, and then as they cross the equator, the Coriolis effect will cause it to actually turn this way. Okay, this is how the winds usually move. But because of this low pressure system that was turning in this clockwise direction, what happened was really the winds that were usually coming this way just died down. So there was no, in a way, wind direction going this way. Everything just kind of died to a standstill around here. And coupled with the tropical storm that was forming here, it started to pull the winds westward. So normally the winds will actually be either southerly or maybe southwesterly, okay, or maybe southeasterly. But now because of the winds dying down here and pulling it from the eastern Philippines there, the winds actually end up going westward like this, which is actually an unusual occurrence. And the winds not only pull, or rather these weather systems not only pull the winds in a westerly direction, but it also drew moisture away from over Sumatra, which caused Sumatra to be very dry. And that's why the number of hotspots suddenly spiked to beyond what is normal in June. So this is a humidity map over Sumatra. As you can see, the long-term average humidity for Sumatra is probably over 80%. But from 13 to 24th June, when it was the worst period for us for haze, it actually dropped to about 70%. So you see very dry conditions over Sumatra, causing fires to break out in an uncontrolled fashion, and then the winds pulling it in a westerly direction. So this is another picture. You can see most of the time, the long-term direction of the winds tends to be from the south, but very unusual. On 13 to 24th June 2013, the wind started to move from the west. And this is the reason actually why we are quite fortunate. We don't get the haze very much every year, but Malaysia does. Take a look at the map of where we are in relation to Riau, where the fires are the worst. You'll see that Malaysia gets it. Whether the wind is southwest, southeast, or south, they get it. But for Singapore, you only get it if the wind is almost westerly. Anywhere else, most of the time, the wind does not carry the haze to us. Until later in the year, when it goes further down to South Sumatra. Then, from there, you tend to get it if it is southwesterly or south. But in the start of the haze season, when the burning is actually probably at the worst in June, July, we tend not to get it. Malaysia gets it. They get it every year. We are very fortunate that we don't, but this year woke us up to the possibility that, just was a change in wind direction is what's keeping the haze away from us. It's not that the haze actually, or it's not that the fires are actually not occurring in other years. Okay? It's just that the wind is in our favor. Let's take another example. Okay, in August 2012, you can see the winds were blowing mainly from the southeast to the south-southeast. We were not affected by the haze, even though you can see there is haze forming over Sumatra. But a month later, 3rd September 2012, those of you that remember, last year actually on 4th September we had a haze episode. It actually lasted, I think, maybe 2 days or so, when our PSI went to about 70 to 80. Enough to be noticeable. Why was that so? Again, it wasn't so much that the fires were getting that bad, it was because the wind changed direction. So take a look at this. If it blows in this direction, you don't get haze. If it blows in this direction, you just change it a little bit, you get the haze. But Malaysia gets it all the time, no matter where the wind direction is. So this is an animation that I got from Chris. It was taken from these organizations. And okay, if you take a look at the GIF file, you can basically see, all right, this is Riau. right? You can see a tropical storm forming here, right? You can see the low pressure system forming here, and you can see the winds are just cooling moisture and the wind direction to here. So that's really what caused the haze. And many people, when the haze came, say that NEA, why you never give warning and everything. Actually, that's not really true. We issued under the ASEAN Specialized Meteorological Center, ASMC, level 1 alert on the 14th of June. Okay, I remember all these days very well because I went through the whole thing. 14th of June was a Friday. I remember on a Friday the PSI started to reach about 70 over. It was noticeable. We issued level 1 alert. Over the weekend, the PSI stayed towards the moderate range. Okay, not too bad, but enough that you know there is something there. I think on Monday it went down a bit. On Tuesday, I remember it spiked up to close to maybe about 100. Because I remember I was in Jurong, I was in JTC, and when I stepped out of the meeting at about 6 p.m., I stepped out of the building, it was a lot worse. And then of course it got worse over the next few days. By 17 June, we actually had issued ASMC alert level 3, which is the highest haze alert level that there is really. And then of course things really started getting really bad. I remember we flew to Indonesia, I believe on the 18th. I remember the night before, I was in the office, I was frantically trying to do this sort of Google presentations because the next day we had to fly to Jakarta and I had to go and demonstrate to Indonesians, and I'm not a Google expert or anything. I was trying to get all the animations and all the files to work properly. I was in the office until very late. And the PSI just kept spiking. By then we had already started reporting the 3-hour PSI levels. And in the evening, in the late afternoon, it was 100 over, and then we were joking, okay, how high can it go? And suddenly it went 170, and next thing you knew, it went 320. And then the next morning, when we had left and we had reached Indonesia, it had reached to 371. And then the next day, when we flew back, I think it had reached 401, which was the highest 3-hour PSI that we ever recorded. But why is it so difficult for us to actually predict the haze? Well, here's the reality. We have very little data coming out of Sumatra. Most of the time when you see meteorological services being able to predict weather systems, days in advance, it's because of two reasons. One is they're usually in temperate countries, whereby the weather systems are a lot more predictable because they are more long-term. So you hear all these temperate countries, they talk about, low pressure system, and you kind of can predict 4 or 5 days in advance. Tropical systems don't behave the same. They're a lot more unpredictable. Secondly, many of these met services, they are the benefit of having many weather stations in surrounding countries that actually give them data. We actually have no data coming out of Sumatra, virtually none. We have some weather stations in Sumatra, maybe in their airfields. They give it to us, but Sumatra is a huge place. They only have a few coming out there. We have no PSI data coming out from Sumatra. Zero. You go and Google the PSI levels that are reported in Indonesia, in Sumatra. You look carefully where they come from. They come from Chevron. Because Chevron is a major oil-producing operations in Sumatra, and they are the ones who maintain the air monitoring stations. They are the ones who report the PSI. It's not the government. So Singapore is hampered, we are very near Sumatra, but yet we virtually know nothing of what is happening on the ground in Sumatra. So just imagine, the satellites pass over once a day. Okay? If you're lucky, we see the hotspots. If you're not, and there's cloud cover, you don't even really know what's happening there, even though, of course, you can still see some hotspots. Again, if you're fortunate and there's no cloud cover, you see smoke plumes. If it's cloud cover, you see nothing. So you can't really tell the hotspots, how bad they are, how big the smoke plumes are, or is it even a fire in the first place. Then you have no local PSI readings. So how do you know whether the haze is going to come to you? And we actually don't really have a lot of wind data coming from Sumatra either. And they are so close to us, okay? If the wind just changes direction within one day, it will actually blow in our direction. So when people say that, oh, at EA1 you never predict everything, the reality is that it's virtually impossible for us to do so. We issued the alert levels as early as we could. And if you look at this regional haze map, on 15 June, okay, this was, remember 14 June was the day the PSI went over 70. On 15 June, the hotspots don't look very bad, okay? We have no discernible big haze cloud that we can see. But suddenly on the 16th, okay, we see some haze clouds forming. But where are they? Okay, they're near us. Again, you can't really tell how's it going to go, how severe it is. And 17, you know, the haze cloud kind of just moves a little bit, and how do you know whether it's going to be hitting us or not? And now all of a sudden at 18, not only you see the haze cloud, but you see one area that's dense haze. So this is the problem. We can only see it once a day. Okay, it gives us very little time to react. And then 19 June suddenly envelopes the whole of Singapore, southern peninsular Malaysia. So let's look at the satellite map itself. Okay, on 14 June, you can see the winds are starting to blow from the west, and already there's a little bit of trace of haze. Now, again, just imagine you're the Met Service officer, and you look at the map, the picture on the left. Can you actually tell where the haze is? It's a guess, right? I mean, on the right is easier, right? You can kind of see the smoke by its color. Can you really tell on the left? But this is what our Met Service officers have to look. They have to look at maps that are only of this granularity, and they have to make a guess. Where exactly is the haze, and is it going to come towards us? So by 19 June, you can see we are enveloped by dense haze, really. Okay? So the thing changes very quickly in just a few days. Of course, this is quite a famous NASA photo, much further away, but now you can see the whole region. You can see westerly winds blowing huge smoke plumes, okay, coming from Aceh all the way, covering Singapore, southern Malaysia, all the way into the South China Sea. Of course, our PSI readings, like I said, just really spiked. 155, 321, 371, and of course, all-time high for 3-hour PSI, 401 on the 21st of June. This is the haze map for 20th of June. Singapore's right at ground zero. That's why we got it so bad. So on 20th of June, I was in Jakarta. We flew back on the 21st of June. And this was the newspaper headline in the Jakarta Post on 21st June when we got up and we had breakfast. Only rain can help Singapore now. Basically, Indonesians are saying, you need a miracle. There's nothing they can do. Which was quite worrying. I mean, you go over there hoping that they'll take action, right? And then firstly, they tell you it's a natural disaster. It's caused by a storm. So it's not their fault. Which it turns out is okay, partially true. And then after they said, well, there's nothing we can do, only rain can help you now. I was a bit annoyed when I read this kind of headline, but I mean, what can you do, right? It is as it is. So we flew back on the 21st of June, and frankly, I wasn't sure that we could even land in Singapore, because before we took off, we already knew the PSI was approaching 400, and we really didn't know whether a plane would even be allowed to land in Singapore, whether the airport would be shut and so forth. But we did manage to land. And it was quite shocking because I took a cab back from the airport, and I never actually seen the sky and the air so blurred in my life. I've never seen 401 PSI. And nobody in Singapore had ever seen it. So it's a huge shock to everybody. So you all know this is how it was like at 12 p.m. at 401 after I landed. It was 401. It was incredible. It was incredibly bad. This is the haze map on 21st June. Now, the same day, okay, my minister developed an envelope to the Indonesian forestry minister. Okay, all this on the record. Don't go and record what I said. You know, you read online chatter. There's a lot of satire on this, right? They say, oh, he was handing money over them and so forth. No, he handed a letter from our prime minister telling them, hey, we will do something about it. Now, to the credit of the Indonesians, they knew that it was a disaster. And they knew that internationally they were already facing into a public relations disaster because it affected so many people that they really, they couldn't deny that it had come from Sumatra. There's no doubt that it had to do with forest fires. And so they sent in their army and their air force. They sent in, I think, a few thousand soldiers to help the local fire brigades fight it. Which was important because, Sumatra is a huge place. Their local fire brigades, there's no way they can fight fires of this scale. They sent in the army, they sent in their water bombers, their air force planes and so forth. They did cloud seeding, everything, and they managed to get the things under control, which we have to be very fortunate. I mean, we can consider ourselves very fortunate, because if they had not, remember, these are peat fires. Once they go out of control, there's no way of stopping it for several weeks. Then we are very thankful that they managed to control it and the situation rapidly improved. So this was on 21st June, it was a Friday. Okay, I remember it because we came back and then he went there to Jakarta. And he went there just to deliver his sample and then he flew back again. And then my 22nd, which was a Saturday, I remember, okay, I was out. And then all of a sudden there was clear sky. So after 1 week of, just non-stop grey skies, suddenly there was clear skies. And why? It's because, okay, two reasons, okay. One is there was a gap in the haze plume. There just happened to be a gap, and in the afternoon, suddenly the whole of Singapore suddenly saw blue skies for the first time. And then the winds also started to change direction. Okay, so it was going due west. Now it started to go a little bit more southwest. So it started to take the haze away from us, but of course it just moves it northwards, which means, it just moved to Malaysia. And I remember this very clearly because I was recalled back to the office on 23rd June, which is a Sunday. Yeah, I was recalled back to the office. There was everybody in the office, and at around noon, we heard that a state of emergency had been declared in Muar, because their API, which is roughly equivalent to our PSI, had reached 746. 746, I mean, ours was 401, theirs was almost double ours. It was very bad. As you can see from this, the haze just simply moved northwards. It took a few more days for the haze to dissipate. It enveloped the whole of Malaysia at one stage before dissipating. But you can see by 24th June, it covered everywhere except Singapore. I must admit, I was a bit skeptical when I saw this. I mean, I was saying, okay, first of all, how do you draw the map? How is it so nicely it can cover everywhere except Singapore? Okay, but the map is what it is. Okay, I can't tell whether you drew it correctly. But it was all over Malaysia. We started to have our air quality improve. And then it was in a moderate range, and then gradually it went back to the good range. So these are the satellite photos. You can see it moving up. You can see on the right side, very, very bad over Malaysia. So it went up to Muar, then to KL, and to Penang, and so forth. So they really got the full brunt of it. Now, throughout this whole episode, we started to put something on our website that we had never done before. We remember all those high-resolution photos that I showed you previously. Previously, we had just given them to the information, but we decided early on in this episode, why do you have to hide it? I mean, this is what's happening on the ground. Let's put it on. So we put the Google Earth, the KMZ files on the website. If any of you all had downloaded it, you could have done all this yourself, because you can just run it on Google Earth. We had the hotspot data, we had the smoke plumes, and some of them, of course, are very dramatic. And you can see clearly these are man-made fires, because you can see the grid lines of the plantations. So where the canals are dug and so forth, there's no way that these are natural fires. They're not in natural forested areas. These are man-made fires, and the smoke plumes are huge. Okay, this is area south of Pulau Mendor in Riau. Massive smoke plumes. Okay, and Pulau Mendor is actually not far from Singapore. It's at the most 150, 200 kilometers away. So it's only a few hours away if the wind blows in our direction. Okay, more fires. These are the kind of high resolution that we have access to. These are actually all commercially available. You can buy them. Okay, they are not spy photos or anything. You can see for yourself. Okay, this is what we saw. And we put all this up. Right? This is what's happening in Sumatra. And a lot of these things were the things that actually pressurized the Indonesians, that they really had to do something. Controlled man-made fires surrounding but not encroaching to all palm plantations. You can see for yourself, the all palm plantations are clearly delineated. Fires are coming from outside. They are controlled fires. Okay? These are not man-made fires. I mean, they are not natural fires. So at the same time, we started putting out all these things, and NGOs also started to name and shame companies. They helped us put the pressure. WRI, World Resources Institute, Greenpeace, Eyes on the Forest, World Wildlife Fund, they all started to name and shame companies. And that's when you started to see public mention of this haze monitoring system. Okay, this how it started. Okay, right? I shared. We created it in 2012 as a prototype. By October 2012, ASEAN had said that okay, please go ahead and develop it. So throughout the start of 2013, we were actually building it into a more formal system. So by 17 July, the system was more or less ready, and I went again to KL, to the Ministerial Steering Committee on Transboundary Haze, whereby I demonstrated a system, now a slightly more advanced version of the system. And that's why my minister talked about, no, we have to share the maps. The maps here meaning the concession maps. Because without concession maps, there's no way of identifying the companies. The whole point is to identify the companies. Of course, they resisted, as they are still resisting, right? Because land ownership data is a very sensitive issue. Right? You can understand why, right? If you are from Malaysia or Indonesia, you don't always want to let people know who actually owns the land. And so maps is a very sensitive thing. So we pressured them, they didn't agree. But they didn't disagree either, so at least we have something to proceed on. And then just after we left, KL got the haze again, 23rd July. But we didn't, because remember, wind direction. So actually for the whole year since June, we have, I think maybe only once or twice gone into a moderate range. KL on the other hand, since June, I think went into the unhealthy range twice. And for many days, actually, large parts of Malaysia are in the moderate range. So again, remember what I said, they actually get it for several months on end. We don't, okay? And we are very fortunate in that respect. Now finally in October, which is last month, the ASEAN leaders gave a go-ahead for the joint haze monitoring system. So finally they have agreed, yes, we'll adopt it for monitoring. The leaders have all agreed. What they have not agreed is when they are going to give us the maps. They still say that they have to consider and everything, but they didn't say they won't give it. So we remain hopeful. But you can imagine now with the maps, with the photos, everything, we are ready for next year's haze season. We can actually put all the information out there. It could be made public if we really want to. And what the NGOs are doing, which in a way is what the HMS is doing, we can do it in a much more automated fashion because our system actually has a lot of functionality built in. So what the HMS looks like, it's actually a lot more advanced than this screenshot because this screenshot is several months old. This was the initial version. Like I said, we have 3 main data sets, the hotspots, the satellite images, and the concession maps. We just overlay them. Okay, you can mouse over, you can get all these data appearing. This is how the map data looks like. And then gradually, from there, of course, we can identify the companies. But more importantly, we can actually track land use over time. We can identify areas that have been deforested. We can identify peatland that has been exposed and then turned into plantations. We can identify exposed peatland because that is most likely the parts that will burn next and burn most severely. So this system is quite powerful because if you really want to use it to its fullest extent, it can be a sort of prediction model and it can even help direct your firefighting efforts. Which is why we're interested and we're excited to use it in a much bigger way. Of course, all the other countries have to agree that they want to use it this way. Now, of course, Chris, for many years, have done land use analysis, time-lapse analysis. They can actually trace, using high-res photos, the change in use over time. They can actually see forests being cleared, then canals being dug to drain the peat. They can then use Landsat imagery or other kind of satellites to actually see what the crops being grown and then they're harvested and so forth. So you can actually trace it over time. But more importantly, you can actually start putting ground-truthing evidence. So I talked about Amazon, which was the system that inspired us in the first place. What they do is they give out to their forest monitors smartphones. And then these people go into a field and then they take pictures of deforestation and then it's automatically uploaded onto Google. So you have the high-res satellite photos and then of course you have the actual photos taken by people on the ground. Conservation Drones is another very interesting company. It's created by Koh Lian Pin, who is actually an adjunct professor at NUS. He's also from ETH Zurich and he started his company and they are very active in conservation work using UAVs. He has, I think, 2 drones flying in Nepal, but he has also flown them over Sumatra and I think Sarawak and so forth. So these are all potential because UAVs are very common now. If you have a UAV that is, $2,000-3,000, you can actually launch a whole fleet of them, and they can cover a lot more area than a human being can. They can spot fires a lot faster than any human being. They can also direct firefighting efforts and so forth. But what's exciting is what's coming next for satellites. Earthcast is an interesting company. They are trying to be the equivalent of YouTube and Google. So Google is like static image, right? YouTube is videos. They want to sort of like merge the two together. What they're going to do is they're going to launch a high-resolution video camera onto the International Space Station, and then they claim you'll have near real-time video imagery as the satellite passes over. And this high resolution, you can, I think, see down to 2 meter resolution and so forth. So in theory, if you know the satellite is passing over, you could go out onto your house and go and wave to a satellite. Maybe 20 minutes later, when the image appears, you can see yourself because you'll be able to zoom in. See? The whole point is, it's there. You can do whatever you want with it. You can zoom in, you can zoom out and so forth. So it's potentially very interesting. I was very excited when this thing came out until I realized that they wouldn't pass over Sumatra that regularly because they have to cover the whole Earth. So the NASA satellites, because they are in a certain polar orbit, they pass over Sumatra twice a day. So they have 2 satellites. Okay? One passes over in the morning, one passes over in the afternoon. Then the NOAA satellite also passes over. So overall, we have 3 satellites that pass over Sumatra every day. Those are not very high resolution ones. Then we have the high resolution ones that I showed you. Those actually only pass over Sumatra maybe several times a week. So that's another problem that we have. Not only do we not really know what's going on there because we lack PSI data, but the high resolution satellites don't pass over as often as we want to. And from NEA, it's a bit of a gamble. Because if the satellite is passing over the high resolution ones, and if I want to track it to say I want to take a picture of this area, I have to send an instruction to the satellite, and it costs a few $1,000s. So the satellite will turn its camera and it will take a picture. And 70% of the time that's cloud. But the satellite provider doesn't care. If he shows you a photo that's cloud, you pay $5,000 anyway because that's how much it costs them to actually track the camera to take for you. In an ideal world, we would have our own equatorial orbit satellite that passes over this region along the equator 12 times a day. Then that's the best, okay? I can take pictures 12 times a day. It's much more likely I can actually spot the fires much faster, but we don't have that. Okay, we don't have that sort of satellites up there, but it will happen. This is a commercial company, Earthcast. You can imagine once they put it out, if it's successful, there will be many people that will be launching their own either microsatellites or putting on the ISS. Pretty soon, many places on Earth, I am sure, within the next 10 years will be monitored 24 hours. The interesting thing about Earthcast is that they partnered with this NGO called Deforest Action, which was something that started in Singapore, and Deforest Action wanted or wants to monitor illegal forest activity using school kids. So they will assign school kids to say, okay, your school, please monitor this 1 by 1 square kilometer area, and we'll just feed you the satellite images, maybe, I don't know, every 2 weeks or something like that. And your job is just to look at the area and spot whether there have been changes in land use. If it is, email to us. We'll get some rangers on the ground to go there, verify whether something illegal is going on, and basically provide more eyes from the sky. So this is a very interesting thing because it kind of crowdsources something that otherwise would be quite labor intensive. So Earthcast is partnering with Deforest Action, and they have a planned collaboration for real-time high-definition video of deforestation in Southeast Asia. I think this is quite exciting. I mean, it doesn't have to be to school kids, right? It can actually be to anyone. You can go and sign up for it if you want to. So imagine next time, okay, you may have tens of thousands of people all over the world monitoring Southeast Asian forests for various things. Okay, it can be deforestation, it can be for fires, it can be for all sorts of illegal activities, and that I think is the future of environmental monitoring. Okay, so we have a choice. we are at the sort of crossroads. I already talked about how we have lost 40% of the lowland forest cover in 15 years. If we do nothing, most of the rest is going to be deforested. The trend is clear. If you just extrapolate the trend line, it's a very depressing story. But we have the chance to keep the forest in as pristine a state for as long as possible, provided we know what's going on there. So we really are at the crossroads. We can either have it look like this. If we do nothing, this is how it's going to look like. And the haze is going to get worse and worse. Large parts of Riau and Jambi have really been deforested for pulp and paper, for oil palm. There's almost no hope for the rest if the world doesn't want to do something about it. Because over there, they'll just give out the land, and once they give out the land, they will do something to develop the land by cutting down the forest. Or is there a middle ground? Pure conservation also cannot work. People there have to have jobs, and they quite rightly say, what's in it for me to keep the forest pristine? I need to earn a living. So maybe Willie Smith and his model of having agroforestry is that middle ground, whereby you have something that looks a little bit like this, avoiding this, but yet economically useful, preserving biodiversity as much as possible, preserving livelihoods as much as possible. How will environmental monitoring look like in the 21st century? So I talked about haze, but it applies to every aspect of NEA work. Environmental protection, public health, med services. Let's take another example. This is not haze, this is industrial pollution. You know that in Pengerang, the Malaysians are building a very large petrochemical complex and refinery complex. Where's Pengerang? You may ask. Okay, Pengerang is here. Okay, it's quite close to Singapore, probably only about 10 kilometers from Changi. And it's a very huge petrochemical complex. It's going to be somewhat approaching the scale of Jurong Island. What's scary about Pengerang? This is the normal wind direction, southwest monsoon, right? This is actually why the western part of Singapore has worse air than the rest of Singapore. I mean, this is no secret, even though we don't have to talk about it. It's because there's a lot of industrial activity in the west. So far, I live in Pasir Ris, I live in the northeast, and it's quite clear. When the wind direction changes at the end of the year, when the northeast monsoon comes, where do you think the pollution is going to come from? So half the year, it comes from the west, half of the year it comes from the east. If we don't make sure that the pollution is within acceptable limits, I'm concerned about what it means for Singapore. Okay, now it doesn't mean that things are bad. Okay, I'm just speculating a worst case scenario, but you can see that we are a very small island, and surrounding us are factors that are beyond our control. If we don't monitor them now, if we don't have a baseline of what's happening, and so that next time we can tell whether it's gotten better or for worse, we're going to be in serious trouble. Because if you want to go to Pengerang in 5 years' time and say that you're causing pollution, it's very easy for them to say, how do you know it's wrong? If we don't measure baseline today, there's no way that we can prove that things have gotten worse. So baselining is a very important part of environmental monitoring. But now the baselining is cross-boundary, trans-boundary. I can't put a sensor on the smokestack in Pengerang. I have to measure it from 15 kilometers away. How am I going to do that? I have to use LiDAR, radar, not LiDAR, it's a sort, I mean not radar, sorry, it's a sort of laser, basically, that can measure pollution levels in the air. And this kind of what we call standoff detection has many users, okay, not just for transboundary. The smokestacks on Jurong Island, if I can put something on the mainland, I measure them from 5 kilometers away, I can measure the pollution that's coming from them a lot better than I do now. Today what NEA does is for the major emitters, we actually put sensors in the smokestacks. But of course that means that there are a lot of factories that we don't. Okay, so if you want a complete picture, you shoot from 5 kilometers away, just shoot the LiDAR and be able to measure it at real time. I also have Malaysian vehicles coming into Singapore every day. Many of them are smoky. Of course, we stop them at the border. I have been on a raid Yeah, it's very interesting. If you ever get a chance, I was at Woodlands Causeway. So there's an NEA contingent, a small group of people. They actually stand at the causeway and just check for smoky Malaysian motorbikes. And they just stand there. And what happens is that 100 meters further up, when they spot a smoky bike, they will walkie-talkie the guy 100 meters down, and then all the Malaysian motorbikes have to pass through this narrow one-lane road. So we will tell them, stop, pull to a side, rev the engine, and under our act, if I see any sort of smoke, I can fine you. I don't have to measure the intensity of smoke. If I see any sort of smoke, I can fine you. It's an immediate $70 fine, which actually for a Malaysian person coming into Singapore is a lot of money. It's $70. And it's because we enforce it quite rigorously that the number of smoky Malaysian vehicles over the years has actually dropped a lot. If not, today you'll see a lot more than you currently see. So these are all the silent work that NEA does to actually keep our air as clean as possible. Then of course ships. They pass through Singapore. Sometimes you see ships emitting black smoke. Again, how do I track them? How do I track them, especially at night? I need to have environmental sensing. So that's on the air side. Okay, there are lots of things that we're trying to do to detect fugitive emissions of hydrocarbons. I talked about standoff detection, smoky vehicles on the road. We could have blitz, like what we do with the traffic police, but how many can we catch? We need an automated system that catch people in the act. So one of the things that we're trialing really is an app whereby, because so many people have dash cams now, right? There's a way you can just press a button, record the smoky vehicle, and then automatically it sends it to NEA. It's a lot easier than today, whereby if you're the driver, how are you going to take the phone out and then break the law by trying to video the thing for 10 seconds, if you can, and then after that decide where you're going to send it to. So we're trying all these apps because more and more people have dash cams. I think this has a potential to actually crowdsource some of our enforcement actions. We already have a very good network of island-wide monitors for air, water, land, and noise. For air, we have air stations all over the island. We have 8 coastal water buoys that measure our coastal water quality. So it tells us, whether we are having pollution from our own ships, our own shores, or they're coming from elsewhere. But in time to come, we want to have more. Then, of course, we're also monitoring noise. Near here at Clementi, we have a wireless trial, noise monitoring trial, whereby we're trying to baseline what is the noise level at Clementi. And we're trying to find, are there hotspots of noise, what's causing them. And over time, we want to create, like I said, that baseline so that you can tell over time whether things are getting worse or not, and pinpoint sources of noise. So noise, wireless sensor network, curbside enforcement against noisy vehicles. Again, people will do illegal modification of engines. We need to find a way to actually get them in the act. Because today, if we give a summons, we have to tell them, bring it to VICOM to check. So you know what these people do? Of course, before that, they dismantle the modification. They'll go to the place, then they'll pass the test, and then after that, they'll put it back on. I mean, it's a cat and mouse game, right? So we can only do that if it's some sort of automated detection. Then, of course, one of the HDB new towns that will be up is Tengah. Tengah, is next to Air Force Base. It's very noisy because the F-16s are there. And if you're going to have HDB towns next to it, you're going to probably find some way to either design the flat so that they can't block out noise, or is there a possibility that you could create noise control systems? We don't know. Even on something like hawker centers, we need all sorts of surveillance. We need to survey whether there's illegal smoking, illegal touting, whether illegal subletting of stalls. We're trying to see whether the video analytics can help us determine, is the hawker center very dirty? Are the plates not clear? Do we need to deploy more cleaners and so forth? So there are many things that these video analytics can help us measure. And then thermal mapping. That's another thing that's quite important to us, because once in a while we have complaints that this hawker center is very hot. And you know, hot is again one of those things that's very subjective. A lot of times the grassroots leader will say it's very hot. When we go down there to measure, it's not hot at all. And we can't figure out, you know, was it transient, was it real, or was it just subjective? And you can imagine it's very labor intensive to send people down just to go and measure temperatures at that point in time. So we need something that can help us measure it on a real-time basis. It will also help us to design new hawker centers. Okay? And then of course we are trying to do some of these environmental sensing and vector control. One of the trials that was mentioned in the newspaper, which I was also involved in, was the UAV monitoring of inaccessible places for mosquito breeding. We actually did a trial here in the US. We did it with a company, and they flew over certain of the gutters here, and we found that through certain specialized cameras, we could detect the puddles of water, which could indicate that, you know, there are mosquito breeding grounds there. But UAVs are a very big challenge in Singapore to fly, mainly because of airspace and privacy considerations. So this is something we have put on hold, not because it's technologically not feasible, but because the privacy and the airspace requirements are, I think, insurmountable for our urban environment. But it is still an idea. Because right now, these places, we have no way of checking at all. For workplace safety reasons, we cannot ask our inspectors to climb more than 2 stories. So it's too dangerous, and they have the right to refuse. So anything beyond 2 stories, we simply don't know what's going on in the gutter. And for many of these old buildings, they have all these gutters that could very well be mosquito breeding grounds. We simply don't know. So the UAV is one way that, you know, we could fly, and at least we could see whether there are puddles of water. Then of course, I mean, why stop at mosquitoes? You know, can we track rodents? Can we put a sensor on a rat and then see where they go into? And then you put enough, and then on the image you see all the rats, all the dots all congregating on one spot. You know, I mean, it's a pretty good sign that there's a burrow there, right? Then you can do something to actually exterminate them. So all these are all possibilities. Public cleanliness, littering, the big area that we have to think about. Again, our enforcement officers cannot be everywhere. We have to try and spot people who are littering. But maybe more importantly, we have to audit our own cleaning contractors to make sure that when they say they are there, they really are there and they have finished cleaning it to the standard that we want to. So we're leveraging on LTA highway cameras to actually check for litter or debris on the roads. Some of these cleaning trucks have actually cameras located behind them, fitted with GPS, so that when the cleaning contractors clean the road and they report that they have cleaned, we can immediately tell, is it true that they have actually cleaned the road satisfactorily? Then in the virtual world, we look at social media monitoring to identify food poisoning incidents, ideally before they become actual food poisoning. Because the only way we actually know when there's a real food poisoning incident is if someone falls sick and he goes to a doctor, he's diagnosed as having food poisoning, that they have to report it to MOH, then it's reported to us. By which time it's at least 48 hours after the event, because food poisoning takes 48 hours after you ingest the contaminated food. But if through social media you could actually pick up people saying they have bad experience eating it, they have stomach ache, they have diarrhea or anything, hopefully we can track it and pinpoint it and source a lot faster. Because food poisoning is something that once you get, you could have a few hundred people getting it at the same time. So what will the future look like? I think it's exciting. It's likely that in time to come, we'll have 1 million people generating and monitoring environmental data. So that's the key thing. They're not just monitoring, they're generating the data themselves. And governments will be analyzing not just the physical, but also the virtual environment. That is the future environmental sensing. It's not just the physical, even though that's the world and that's the part we have to start with. But I think today the virtual environment gives us the potential to actually predict many of these things in advance. This is another site, mappyhealth.com. They claim that by looking at Twitter feeds, they can actually track disease patterns by seeing, where people are falling sick, and then you can plot it on the map and so forth. So let me just end by a few statements. One, a clean environment doesn't happen by chance. That's something I learned after being at NEA. It is through decades of very systematic policy interventions, infrastructure development, and public education. Going forward, environmental monitoring is going to go from the ground to the cloud. And this is, of course, a play of words. The cloud is not just the sky, it's also the virtual cloud, right? So that's where a lot of data is. It's going to be accessible by everybody. This leads to my third point. We need to have a lot more greater transparency of information. So take a case, for example. There's a lot of this conspiracy theory that we are faking the PSI data. I can tell you it's not true. Okay? There's nothing to fake. The PSI data is what it says it is. But a lot of times you all don't believe it. And maybe that's a problem with our public communications, because we haven't explained it as well as we could have. So people think that, well, you know, if you're not explaining it, then you must be hiding something, and then that's how it can't be done. So personally, I believe that we have to be transparent, because now I'm going to ask people to give data to me. So at the same time, I'm going to show you what I have to. What I want is a day whereby you can interpret the data differently from me. Okay, I'm not hung up about different interpretations, but I want you to get the data from me. I don't want to spend time arguing with you whether the data is fake or it's real. I want you to trust that the data you get from NEA is authentic. You can go and plot it any way you want and visualize any way you want. You can come up with whatever conclusions you want. I mean, that's your right. But let's not spend and waste time disputing whether the data is real or not. To do that, I have to put the data, I have to convince you that my sensors are accurate, they are placed in the right places, they are calibrated properly, and that there's enough information out there for you to use. Okay? Not just as a public, as a member of the public, but also as a researcher, you find that useful. So I'm a great advocate that we got to have greater transparency of information. And ultimately, environmental ownership is something that cannot be owned by the government alone. It has to be owned by the public. So you see that a lot now, right? We have this volunteer corps of people that will start to enforce anti-littering. It's the whole notion. Littering is not something that the government does to fine people who are recalcitrant. It should be viewed as something that is socially unacceptable. And public and social norms stop littering as a first line of defense. It has to be that way, because otherwise, you need an army of inspectors to do all these kind of things for you. So environmental ownership, it's not just by the government may lead the way, but the public has to feel a sense of ownership. So it's the same with pollution, it's the same with things like public health, littering, clean toilets, recycling, vehicles, carbon emissions, and so forth. This shared ownership is something that we have to develop, and I hope that a talk like this and also your studies in environmental management will give you the foundation and the means by which NEA and you, and together with NGOs, and together with companies, and together with the general public, can come together to collaborate and create a Singapore that's even better than what we see on the right-hand side. Because don't forget, not too long ago, we were really third world on the left-hand side. But in about 40 years, we actually transformed ourselves to the right side. But I think there's still a lot more that we can do, and yeah, let's do it together. Okay, thank you very much. Okay, so, yeah, you have any questions, please? Yes. Me from the back first.
Yeah, I was going to say, you mentioned how there's some fires in some of the protected areas in Sumatra. I mean, how many fires are in actual protected areas in Sumatra? Because I think there's probably quite a few in different protected areas, that have been designated by the government as being. So, and also I was going to ask as well, like, what percentage of GDP comes from maybe the deforestation and conversion to palm oil in those areas as well, how much of a driver is that growth in the region?
Okay, I'll share what I know, because a lot of these statistics, I don't have it offhand. If you take a look at work that's been done by organizations like C4, Center for International Forestry, World Resources Institute, they did an analysis of the June fires. They believe about half of them come from concession areas. In other words, land that's been set aside for either palm oil or for timber. Okay, which means, I guess, by definition, half were in outside concession areas, which could be then natural forests, it could just be no man's land, or to be just, you know, state land, so to speak. So my guess is it's probably about half-half. Half are in concessions, half are outside concessions. Now, then the next question to ask is, where did the fire start? Because, okay, this is the interesting thing about Sumatra and Indonesia. When you approach people there, they always say, it started by someone else. You go to the big companies, they'll say it started by the community that's living on the land, or it started by small farmers. You go to the small farmers, they say, no, it's the big companies that are starting it. And everyone blames these phantom squatters and encroachers that come from who knows where. So that this amorphous group of villains that, to be honest, no one really knows. So we have spent a few months asking people. There seems to be some consensus that a lot of the fires that even start within the concession areas are not actually started by the companies. Okay, this is what the companies claim. You see, what happens is that when a company is given a concession in Indonesia, they actually inherit all the people that have been living there. And the people have been living there for centuries. So the government may say, okay, I zone this whole area, this is yours. Then the companies will go in, they'll do an assessment, okay, where's the community land, where are the high conservation value forests that I can't touch, which are the areas I should conserve. And then they'll say, okay, maybe I will just plant 50% of the area. Then they'll tell the government, I'm actually only plant this 50% of the area, the rest is actually not my responsibility, even though legally I've zoned the whole area. Now that map doesn't exist in the public domain. That is a huge challenge. So every time you show a map like this and then, you know, it names a certain company, they'll say, no, it's not me. It's some community on my land, and unless you have people on the ground, it's impossible to tell whether firstly you're telling the truth. And then they'll say, okay, the thing started from them, it's not from me. Again, how do I prove it? Or they'll say it started from outside, and then because it's a pit fire, it spread into my land. So it's very difficult to actually tell what's going on in there. So we have actually always explained that the HMS is a visualization tool to just put down what we know. It is not a tool to actually pinpoint conclusive blame on any certain person or group of companies. But it's a means by which people can start asking more pointed questions, which I think today they lack the information to even ask the questions in the first place. So I think the HMS has a lot of use, and together with what the NGOs are already doing using their own mapping systems, we'll be letting people know we're keeping a close eye on them. So going forward in 2014, we hope that people will be a lot more careful as to how they clear their land, and hopefully the fires will be lessened. But palm oil, in relation to your second question, is a very big cause of the deforestation because it's such a profitable cash crop, and you know, everyone's basically clearing land for palm oil. So it's a very big part of their GDP. Okay, let me talk about EIA. Yes, we don't have a law that that mandates EIA. The basic concern is that it has the possibility of slowing down many things. You know, in other countries, for example, you want to build an incineration plant, it can take years. Because you go through the permitting, the public consultation, it could take 5-6 years before a permit is given, and then you may take another 4 years to build it. So there are many things that just cannot move in many countries because the system is gridlocked. Now that's an extreme, okay, we have the current EIA. That's something that we are concerned with. Okay, my personal opinion is that I don't think we need to go to the extreme, but it probably is useful to have some form of EIA. For a very simple reason, a lot of times people think that EIA is about conservation and biodiversity. But I feel that EIA helps us to do planning. It helps me to define buffer zones, for example. Because right now, my buffer zone concept is a bit blunt. Okay, I just say, okay, this area is industrial B2, B1, and then it means a certain zone. That's it. I try to congregate all the more productive industries together, but it's not very granular. It doesn't cover a lot of things like, you know, specific things on noise and how it adds on to the baseline and so forth. But EIA has the potential to do that. EIA also has the potential of even addressing maybe things like surface runoff, which then contributes to potential things like floods. So today there is, as far as I know, no global model of adding all these things together, which is why sometimes you see unexpected things happening. If you have EIA with a proper baselining, we are likely to be in a better position to actually predict some of these problems and prevent them before they happen. So personally, I like the idea of the EIA, but how we are going to implement it is dependent on two things. Firstly, the economic agencies have to agree, because, like I said, the downside is that it just stops all sorts of development which is also not desirable. So we have to make it not too onerous also. We have to customize it to Singapore's context. And the whole idea of even public consultation is, to be honest, not something that the Singapore government is that used to. It's something that we just started. So to even sometimes put things there and then, and just tell people, please tell me what you think, and have the chance that people will tell you, I don't want it, when we ourselves really want to build it. I think it's a challenge. Okay, I speak from the government side. Sometimes there are certain things that we really want to do. And it is psychologically not so easy to put it out there and be prepared to actually stop, because the people say they don't want it, and how do you know that they don't want it for the right reasons? So that's for EIA. For light pollution, I don't think there's any rule against it. But you're right, maybe that's something that we have to look at. I think recently there was, MND came out with some guidelines to say the building cannot be too shiny, because otherwise, it reflects light onto the surrounding, and then it may end up, like a magnifying glass effect. Yeah, all that is entirely possible.
I wanted to ask, you mentioned it's difficult to predict haze, but I wondered whether once you know that it's here, whether there are any mechanisms in place to monitor the impact on human health during these haze periods. Because I know that overall we talk about 1.3 billion deaths related to pollution, air pollution every year, but are there actually any data or monitoring of how the haze impact?
I don't think that in Singapore we have that much of a long-term research on health effects on haze. And a lot of our advisories on PSI, whereby I say it's unhealthy and do this, are actually based on studies done in other countries. So, as a background, this is why there's also a bit of disconnect by people. We show the 3-hour PSI, but we give advisories on what to do based on 24-hour PSI. Because the health studies have all been done on 24-hour PSI. But, in people's mind, this gives rise to, hey, your 24-hour PSI is not that high, and so you say that it's alright, but, I look out the window and it looks terrible, and then your 3-hour PSI doesn't look so bad, so, it just doesn't gel. And this becomes a public communications issue, which we really struggle with, because there were a lot of calls on us. In addition to 3-hour PSI, why don't you give the 1-hour PSI? Or some people say, why don't you give the instantaneous reading? But the reality is that if we gave the instantaneous readings, there might be suddenly a 5-minute spell, it may spike to 500. And then it may drop to 200, I mean, for all we know, right? And then, do you want to spark panic that at that point in time, 500, what does it mean? Because the effects of pollution are not just the the immediate concentration, but the duration of the concentration. So, to be honest, if you breathe in a 500 PSI haze, it's never going to be good for you, but I don't think a minute worth of that is really going to harm you in any significant way. But if you breathe it for one day, it definitely is a serious problem. So, we have this problem whereby it's not that we don't want to release the data, but how will people interpret the data? But yet at the same time, if I don't release the data, then you have this disconnect, right? 24-hour PSI very low, 3-hour PSI looks higher, but my eyes tell me something. So my immediate conclusion is you're faking the data. You're not telling me the truth. And then you'll tell 50 of your friends, and then your 50 of your friends will share to another 50, and before you know it, 10,000 people will say that NEA is faking the numbers, which is totally untrue. But back to your question, we don't really know. And the second reason why we don't really know, or rather I would say that we don't have that much of our own local health studies, but we are taking a lot from overseas. The second point of uncertainty is that we don't really know the long-term effects of pollution that's coming more from burning biomass. A lot of these studies that are done overseas are actually done from industrial pollution or from emission from vehicles and so forth. But burning biomass emits a different sort of chemicals. And so what's the long-term effect? Actually, we don't really know for sure. So we're kind of guessing along the way. But it's certainly something that we're trying to look at. So health effects is one thing that we're trying to better model. The dispersal modeling of how the smoke comes from Indonesia is something that we're trying to do better. That means that we need to have some data on the ground from Sumatra. For fact, we need better satellite photos, better hotspot data and so forth. And then we need to create a model. To then say that if this is what's happening, then can I predict one day in advance this is what's going to happen in Singapore? Right now, we don't really have that. We're making an educated guess in many instances. But we're trying to do better. Hopefully in time for next year, or if not, for future years, because I mean, the haze is going to be with us forever. So long as Indonesia keeps cutting down forests, it's going to be there. There's really no way to actually prevent it until the market responds and puts in a way a price of deforestation. And if then it translates into the cost of palm oil or the cost of your paper, then the market will respond and then say, okay, maybe I don't want to buy stuff from companies that burn, and then of course then it's down to can I track who is burning and so forth. But today, in the absence of that market mechanism, it's a classic market failure, negative externality problem. So it is a very challenging problem, and of course it has to deal with livelihoods of the people on the ground. You know, if they're poor and pouring kerosene costs $5 per hectare versus getting a tractor costs $200 per hectare. I mean, your choice is clear, right? I'm just going to pour kerosene and I'm just going to light a match. I don't care what anybody says. I mean, that's the reality of what's happening on the ground.
We heard that cloud seeding was one of the measures to mitigate the haze. Could you share with us how effective is this measure?
I'm not really an expert in cloud seeding, so I can't really answer that conclusively, but it was done by the Indonesians, and they claim that they had some effect. I don't think they themselves can quantify what was the effect. My guess is that the fires came under control because the president personally ordered an intervention, and he basically just sent in the army, the air force, their planes, everything to do it, because it really was beyond the scale of the local authorities to do anything. And this is where the Indonesian system, I mean, you can't understand it. Nothing can move until the level below acknowledges it's out of their control. So the local level, the district, has to say that I can't do anything, it's beyond my control. Then he activates like the province. Then the province guy has to say that it's out of my control before he activates the national level. So if none of them at each level wants to admit that they are unable to control it, nothing will happen. So in this case, the president just intervened and he just said, I don't care, I'm just going in to do it. And one of the reasons why he was able to call in more resources was, okay, from what I understand, they call it a natural disaster, which then allowed them to mobilize their natural disaster agency. Because if it was a man-made disaster, the natural disaster agency cannot go in. So, it's very strange in Indonesia. I mean, this is some of the way things work. And that's why you also have to understand, that's why they don't like to respond to pressure from Singapore. Because for them to accept it means they are admitting, I cannot handle it, I need to go for outside help. And it's very difficult for Indonesia to admit that I can't handle it.